Hello, everyone. My name is Martin. I'm here today to talk to you about our research and consequent vision to create a commercial diagnostic biosensor. The technique we have been developing is called chiroplasmonic sensing. And I know that to many of you, those words don't mean much, but bear with me. The product in question is a thin gold film on a plastic slide. And on this film are etched tiny squares, a fraction of a millimeter in size, which you can see more clearly in the gray image on the bottom left. If you zoom in a lot closer, this is where things start to become more interesting. In these squares, there are thousands of shuriken-shaped nanostructures, like throwing stars used by ninjas, as you can see in the leftmost images. The reason they're shaped like this is because they're chiral and small enough to interact with electromagnetic radiation or light. Chirality can be found everywhere, and it literally means handedness. The easiest example is, in fact, your hands, which can be either left-handed or right-handed. Nature holds many other examples like snail shells, leaves, mines, DNA, and proteins. The chirality of proteins is very important because that goes hand in hand with our left-handed or right-handed shurikens. The enhanced electromagnetic light waves created by the gold nanostructures, known as plasmons, will interact differentially with a wide variety of protein shapes, giving distinct and specific signals that we can measure. Now, why is measuring proteins important? Well, typical disease markers are proteins or carry proteins on their surface, making them ideal for targeting. Now, we can't just chuck on a blood or nasal swab sample onto our surface and expect a clear diagnostic response. It would be great if we could, but we've got a lot of different substances floating around in our bodies. Before this, we need to create an environment on the sample that will specifically bind the disease marker protein targets. So I've spent a lot of time working on creating surfaces of different kinds of binders, such as antibodies, antibody fragments, affimers, anything with high affinities for our targets. A simple schematic is shown on the top right of the slide, with our gold sample functionalized with different binders, which only bind the desired disease markers. The advantage of spacing out our plasmonic nanostructures into these squares is that we can functionalize each with different binders. So imagine you land at an airport, and instead of getting tested only for COVID, you could simultaneously get tested for other diseases, such as influenza, tuberculosis, meningitis, anything else with a marker that can be immobilized onto the gold surface. The box chart in the center represents data with different markers eliciting different degrees of optical response. And in addition to people, this technology can also be applicable to the veterinary, medicine, and food industry, which is why you see this lovely image of a dairy cow as well. That's it from me, so thank you very much.